All right, welcome to 7-6 where we're solving systems of linear inequalities. I first want to start by reminding you of when we used to solve more than one equality and we would put it on the same number line. So if you remember back, I don't even know if it was chapter 3 or chapter 4, where we took a number line like this and we would put 1 and 2 and 3, 4, 5, 6, and so on our number line. And if I had to graph things that were larger than 2, I'd put an open dot on 2, and I would have an arrow going all the way to the right. And then if I had to graph things that were also less than 5, I'd put an open dot on 5, and I would draw myself an arrow to the left. And then I would notice that in between 2 and 5, I had a section that was shaded twice. That would be the solution to our compound inequality. Well, we're going to be doing something similar in this section, but this time our stuff will be graphed on coordinate graphs. So our first example is really similar to how we started yesterday's examples, where we really took the system, or we took yesterday inequalities and we plugged in coordinates to see if they were the solution for those inequalities. Well, we're going to end up doing the same thing, but this time it's a system, so we've got two inequalities that we have to double check for. So I would go ahead and I would plug in -3 is less than or equal to -3 times -1 plus 1. Well, I know -3 times -1, that's going to be a +3 plus 1. So I know that equals 4, and that is going to satisfy our first inequality because -3 is definitely less than or equal to 4. So we would say, yep, that coordinate would work for our first inequality. Then we would go ahead and plug them into our next inequality. So -3 is supposed to be less than 2 times -1 plus 2. Well, 2 times -1, that's -2 plus 2. That's going to be 0. So is -3 less than 0? It sure is. Since it worked for both inequalities, we would say that yes, that ordered pair is a solution to the system of inequalities. Okay. There's another example that I want to show you quick. I have to scroll down here on the page a little bit to get there though. In our next example, we would plug in a 5 for the y and a -1 for x. So we would have 5 is less than -2 times -1 minus 1. So 5 is supposed to be less than 2 minus 1. 2 minus 1 is just 1. And so when I write that out, I realize that I have a statement that's not true because 5 is not less than 1. So we would go ahead and say, no, that's not true. We could stop there if we wanted to because we already know it's not going to work for the whole system. But just to double check our work, we might want to plug this in to our other piece, -1 plus 3. So then -1 plus 3 is 2. So 5 is supposed to be greater than or equal to 2. Well, that is a true statement, but since it's not true for both of them, it's not a solution to the system of inequalities. So our answer really is still no. All right, on to example 2 for the next one.